Okay, we're going to go over, review the example that we did last time and then get into a new example of doing razor pages. First of all, can I have confirmation from the people watching online? Can you hear me? Just post in the chat. Yes, okay, excellent. If at any time you do have questions, type it in the chat. I should notice. If I don't notice, if you could resend it, I'd appreciate it. All right, so again, how are we going to open this up? We're going to go to first example. It's over in here. The first example we're going to look at today. I'm going to double click on the solution file. You might get a, depending on what you have installed, you might get a question of what you want to open it up. Just pick Visual Studio 2022. All right. To remind you how this works, or what this does rather, when we run it, it goes, does its thing, displays the page. When we go to our convert page, type in a temperature. 32 Celsius is 89.6 degrees Fahrenheit. And 0 is 32, and so on. So how does this work? This works by us having two things working together, the razor page itself and also the code behind, or the model, I think they call it. I think in the old days we used to call them code behinds, but they're probably more appropriately called the model for this page. If we notice in the razor page proper, what we have is we have a couple of places that are filled in from the model. How do we know what those places are? Because this is a plain HTML file. Remember, this gets added to our layout file, which has all this stuff, including the navigation. This form gets added to that with a method of post. And the two things that we have here that begin with an @ sign mean that the value comes from the model, specifically because it says @ model. All right, I should clarify that. @ model means it comes from the model. What is the model? Well, Razor Pages example 1. There's always going to be, with Razor Pages, there's a one-to-one relationship between the model and the Razor page itself. So this model over here goes with this razor page, the one that ends with the file name .cs. So these are variables that exist in the model. We can look at them right here. At model temp C, at model result, at temp C and result. Now, these get filled in when the page runs. When we run this for the very first time, we're simply displaying the page. We are doing a get on the page. So we are not doing, when we simply click on the link, we are doing a get on the page. We are not doing a post. And therefore, onGet runs. And what does onGet do? Well, it spaces out the result, so we don't see the result anywhere here on the page. I typed in something like first load here, and if I ran it, I'm going to call that onGet, and the result's going to say first load. That doesn't really make any sense, so we fill it with an empty string. This, by the way, is just one way to do it. None of the other fields have values. Therefore, temp C, which is the other value that comes from our model, is set to 0, which is a default value that you get with a double when you declare a double. Now, because this is a post form, when we click the button, we're calling onPost. And what does that method do? Well, that method grabs from the form that was submitted, temp C. How do we know the name is temp C? We know it's temp C because that was the name given the form field. Right? So therefore, that's the name that we grab from the form. We convert it to double. And then we do some arithmetic on it. Multiply by 9/5, divide by 32, or I'm sorry, multiply by 9/5 and then add 32. And that's the conversion for degrees Fahrenheit. We take that temperature in Fahrenheit and concatenate it with the word degrees Fahrenheit, and that becomes our result. We type in, let's say 100 degrees centigrade should be 212 degrees Fahrenheit, and it is. Now, one thing that I want to introduce with this example, and it's a real simple example, so it should be easy to see with, is the use of the debugger. With a debugger, we can put breakpoints on our page. And we can say, for example, this line is a breakpoint. What that means is when we run this in debug mode, when the server hits this statement, it's going to stop execution and show us the values of the variables and everything that we want to see. So if I go up here and I say debug, start debugging, all right, I haven't hit the breakpoint yet because that's on the get, not on the post. I still haven't hit the breakpoint. When I type in a value here and click go, the execution pauses and I continue on. Temp C has a value of 0 before we grab it from the string. We can then do several things. We can step into, step over, or step out. Step into means go into the next line of code, whether it's in the same function or in another function. Step over would say go the next line of code in this function. And step out would be to step out of the function and return from the function. I'm going to do step into, and that's what I normally do. All right. Now in this case, notice that temp C, I can put my mouse over it. Temp C has a value of 11, which is the value that we had in the box. I can step into again. Temp F has a value of 51.8, and then we can concatenate and get the result, and I can just click continue and it will show the result. Now, notice there is no validation performed. All right, so if I type in something like this, I'm going to get an error. I don't want to click convert, I want to click go. There's our error. Let me get rid of the debugging and rerun this. There we go. We get the error. Let me try that one more time without debugging running. If I go to run this, I get in here, I type something that isn't logical, and I hit go. I get an error. System format input string was not in the correct format. I can't convert a string into a double, and therefore, we click continue, we get that error. Now, a couple things about error messages. First of all, this error message is good for us because we're in development mode. A lot of times we don't want the outside world to see the error messages that we get in development mode, all right, because sometimes they can be used against us. So there typically will be a different set of error messages for the outside world when this is deployed. How can we fix this? We could fix this a number of different ways. I'm going to take the easy way out. I'm going to wrap everything in a try-catch block. So I'm going to say try these statements. Catch. And I'm going to put in the result variable invalid entry. Okay, I forgot something. I forgot a semicolon there. So now if I go and I put garbage in here, click go, I get that message, and it doesn't blow up and give me a big ugly error. There's other ways, of course, I could test this. I could write logic to test it, make sure it's a number. If I want to make sure it was within a range, I could do some tests like that and so on. All right. But at the very least, you should catch exceptions. In this case, I'm catching any exception. But really, in this code, about the only thing that could go wrong is the fact that I've entered in a non-numeric number, a non-numeric value, and it gets it's tried to be converted to a double, and it gives me an error. All right. So the key points of this: our Razor page associates the model, which is the .cshtml.cs file, with the Razor page. Where the Razor page has at something, specifically at model, that means it's coming from server-side code, specifically from the model. This at model dot something is going to be variables inside my model class. And then we have code either in the onGet or the onPost, or possibly both, to handle how the page gets set. All right? How the values of those variables get set. OnPost is because we have this form posting its data, and therefore OnPost this means that the data is to be processed. Okay. We're going to go on to the other example. And the other example is a simple dice game meant for kids. And it's called the high-low game. And the high-low game works like this. I'll run you and show you how it works, and then we'll take a closer look at it. So I click run to run this. Brings up my application. I click the link. I come to this page, and I have three choices: low, 7, and high. All right. What those correspond to values of a pair of dice. All right. So if I choose low, that means that I expect the sum of the two dice to be a total of either 2 through 6. All right. If I expect high, I expect it to be 8 through 12. And if I pick 7, I expect it to be exactly 7. Now, without getting into the probability of this game, well, we'll talk about how the odds are stacked against you in this game, but in a second here. Because the value that you could get when you roll 2 dice is going to be between 2 and 12. So this splits it into 3 categories. Low, which is 2 through 6, 7, which is 7, and high, which is a sum of 8 through 12. Okay, now you get paid out based on whether you're correct or not. So the assumption in this case is that we start out with 100 points, let's say, if you don't want to gamble actual money. So you start with 100 points. If you guess wrong, you lose a point. If you get right, you gain an additional point. So if I were to pick low and a 2 through 6 is rolled, I would go from 100 to 101. All right. If I were to pick low and 2 6s were rolled, I would lose that point and I'd be down to 99. Same thing with high. So you get paid even money for low and high. For 7s, you get paid 4 to 1. If I pick 7 and it comes up 7 and I had 100, I'll get paid 100. I'll get paid 4, so I'll be up to 104. If I lose, I only lose the 1, so I'll be down to 99. Now, the odds are stacked against you in this game, as they are in all gambling games, right? Because your chances of rolling a 7 are 1 out of 6, all right? There's 6 possibilities for each dice. You multiply them together. That's a total of 36 possibilities when you roll 2 dice. Of those 36 possibilities, 6 of them are a 7. A 1 and a 6, a 2 and a 5, a 3 and a 4, a 4 and a 3, a 2 and a 5, and a 1 and a 6. So 6 out of 36 will give you a 7, and yet you're only paid 4 to 1. Likewise, if you do the math, your chances of getting a low are 15 out of 36. And that's a little below even money. So again, this is a game that if you play it long enough, you're going to lose. So let's play this a little bit. Let's see if we can earn some points here. I'm going to guess high to start. Oh, I selected low. There's the 2 dice. Dice was rolled with 3 and 2. That's 5. 5 is not in the 8 through 12 range, and therefore we lost. I'll pick 7 this time. Snake eyes. All right, I lose. So I'm down to 98. I'm going to pick high. All right, I won. I'm up to 99. Back down to 98. Oh, there was my 7. All right, I think you see how this works. Now, let's consider how the razor page for this works. Because when we look at this, some of this HTML code is the same every time we run it. This drop down, for example, and the play button are the same every time we run it. All right. However, balance, well, the word balance is the same, but the value for the balance is different. The word results are the same, but what I've selected, the 2 images of the dice, the values, and whether I won or lost, those all vary each time. So we can guess what comes from the model. All right. This is going to come from the model. These 2 images come from the model. Values 3 and 4 come from the model. Whether we won or lost comes from the model. And finally, the balance comes from the model. So let's look at the razor page and let's see how this is a combination of some static HTML that doesn't change, along with some dynamic HTML. In other words, stuff that gets generated by the server. So if we look here, view data title is going to put the title of high-low in that. We didn't notice that, but the title up in the top bar was high-low. The model for this page is high-low model, right? Which is the name of the Razor page. .cshtml.cs. So that associates this model with this Razor page. All right, we can look and we can see the stuff that's static and the stuff that's dynamic. The stuff that's static are things like drop-down. The display of the button. This paragraph here is partly static. In other words, the fact that it's a paragraph and it has the word balance in it is static. Yet at model balance, is something that's coming from the model. It's dynamic. So everything that comes from at model is dynamic. We notice here we have a hidden for field. This simply makes our life a little easier. All right. Because we can go in and pull the value from there to figure out the new balance. I have a section, and the class of this comes from results class. Right? So the section is hard-coded, but the class of it's dynamic. Why do you think the class of it is dynamic? Well, because the very first time we display the page, we don't have any results to show. Notice that section doesn't appear here. Only after we play the game once do we get the results. Therefore, we're going to change the result area from visible to invisible. We're going to start out the first time we display the page with the page being invisible, with the, not the page, but the results being invisible. And then we're going to change it to make it visible once we play the game once. Okay. Now, we have in our CSS file two classes, first time and post back. First time has a display of none, post back has a display of block. So when we look at the model, what we're going to notice is that the first time this page is loaded, this class variable has the value of first time. And second time, each subsequent time, it's going to have the class of post back. Here's the user choice. Here are the images that get displayed. So the model is going to determine what image gets displayed for the first dice, what image for the second dice. It's going to display the values of those. And then finally, it's going to display the results, which are a message saying whether we won or lost. So we can see here that this is a mix of static HTML along with dynamic things. By dynamic things, I mean things that are going to change when you run this. All right. And specifically, it's going to be things that come from our model. So the model gets filled, the variables in this model get filled with their appropriate values, and those values are then used and are plugged in different spots to determine the final version of how the page is going to look. So remember, we get some of the page from the layout. We get all this stuff, including the navigation. Wherever it says render body, That's where we actually put in the stuff that is in the Razor page. So that stuff gets plopped in right there. Everything in this. There's two places the HTML come from, the layout page and the specific Razor page. And finally, part of the page is determined by the values in the model. So let's look at this. First thing, well, we'll talk about that later. We look at the model. Notice that all these things that we define as filling in, getting filled in on our Razor page exist as variables over here. So notice, for example, the first variable is model balance. There is a balance variable that gets initialized to 100 the first time. There is a balance variable that appears here and here. That gets initialized from that variable. There's a results class variable, which initially gets set a value of first time. So when the page loads the first time, the class has a value of first time. Therefore, this section is going to be invisible. User choice is defined as a string. It's wanting us to put question marks after these because they could be null. Go and do that. So, image 1 and image 2 are variables, string variables. D1 and D2 are variables. Those are integers. And finally, at model's result is a variable that comes from model. So we see our model has all these variables in it, some of which are going to be plugged into the HTML. In fact, all of them are, I think, except this tag one, which we'll talk about in a minute here. So we don't have any onGet method. So in other words, no code is going to process the first time it's loaded. The first time it's loaded, no code processes, and our model has a value of results class for first time. Therefore, this section gets set up with a class of first time and therefore has no display as we defined in our CSS. So this only runs when there's a post back. So I grab the value of user choice from the form, the variable user choice. Right? What does that mean? Well, that drop down has a name of user choice. So we use the name from the drop down to say request form, and that's where we get this value. Balance pulls the value from that hidden form field. All right. We have to create a running balance, and therefore we're going to put that in the hidden form field and also on the display. We randomly roll our dice. This creates a random object. This generates a number from 1 to almost 6. All right. This would actually generate a number from 1 to 6.9999999. And because these are integers, that gets truncated and therefore effectively we get a random number from 1 through 6 for each of the dice. Right? So D has a random value from 1 to 6. D1 rather has a value from 1 to 6. D2 has a value from 1 to 6. We then have our if statements. If the user chose low, notice I'm using a dot equals. It's important to do that instead of saying this. The reason we do this is strings are objects. And when you compare objects this way, you might not get the result that you want because it's comparing to see if it's the exact same object and not whether they have the same value or not. We're going to compare to see if the value from one string equals, the user choice string equals low. If it equals low, this is the way that we evaluate whether the user has won the game or lost. If the user picks 7, this is how we evaluate it. Finally, if the user selected high, this is how we evaluate it. So, if the user selected low, we add up the 2 dice, and if the sum of the total is less than 7, we set the results variable to winner, and we increment the balance by 1. Otherwise, we set the results to loser, and we decrement the balance by 1. If the user selected 7 and the results are actually 7, and again, we can use a double equal sign here because these are primitives. These are not object references. And so you can do this comparison just fine. But anyhow, if the sum of the dice equals 7 and the user selected 7, then we have a winner and we increment the balance by 4. Otherwise, we have a loser and we decrement by 4. Finally, if the user selected high, we check to see if the sum of the 2 dice is greater than 7. If so, we have a winner. If not, we have a loser. Let's forget this tag over here because I'm going to use that to just sort of demonstrate something that just for the heck of it. All right, just to demonstrate how we can use values from the server almost anywhere in our Razor page. We set the results class to post back. What does that do? That makes the results section visible. Results class is what the class of that results section is going to be set to. We then form the name of the image. All right. Now, if you look, where are we going to put the images? We talked about this a little bit last time, but we didn't really go into detail. We're going to put those images in somewhere in the www root folder. Images are not files that the server needs to process to send to the client. Razor pages and the models are files that the server needs to process. So those pages belong in the pages folder. Everything else like the CSS, any JavaScript files we have, or the images appear in www root. And in this case, I put an images folder. And I have 6 images, each corresponding to the different values of 1 dice. D1, D2, D3, 4, 5, and 6. I form that image variable. If they rolled a 1, that image variable, image 1 is going to be d1.jpg. If if the second dice was a 6, image 2 is going to be d6.jpg. And then all these things are used to fill in this. Now, in the case of the images, we have to specify the path based on the web server's root, which is what this tilde indicates. So in the web server's root, there's a folder called images, and the image name is contained in the variable in the model image1. Now this works and all, but I'm going to set up debugging anyhow. I'm going to set debug to land on this statement, so I can go through and look at the values of each of the variables that got set. So I run this. Pick 7. I can look at the values. What's the user choice? It's 7. What's the value of D1? I rolled a 5. Might be a little hard for you to see, but I'm putting my mouse over the variable. What's D2? 2. What's the result? Winner. Image 1 is D5.jpg. Image 2 is D2.jpg. The result class is postback, and the balance goes up to 104. So those values for the variables are going to get plopped in to these locations in the Razor page as soon as I continue. Sure enough, there they are. All right, a couple key points I want you to be sure to understand. Notice how I can put variables from the model just about anywhere. By the way, in addition, the balance is remembered from time to time because along with being displayed on the screen, it's displayed it's held in a inner hidden form field. So the next time I run it, it's going to know the starting balance is 104 and not 100, which is the initial start. But notice in the Razor page, what I use stuff from the model for. I use it for an attribute of an HTML tag. So this hidden form field gets set, the value of it gets set from the model, from the balance that's contained in the model. I use it to display text on the screen. In this case, also the model balance. I use it to display, I use it to display text on the screen. I use it to set another attribute of the HTML, in this case, the class. I use it to display more stuff on the screen, here, here, and here. And finally, I piece together parts hard-coded, parts from the model to form an image name. All right? Because this part is hard-coded. We know that all the images are in a folder off the root called images. But the name of the specific image we want is contained in the model variable image1 and image2. Now, one thing I didn't show that I can do is I could use actually this variable here, let's say, turn off debugging. I could actually use a different tag and put a tag name in a variable if I wanted to. So in this Razor page, I could say that this result comes from and the ending tag comes from and then I can fill in the value of the tag that I want here. Now, just for laughs, fill in a different value for the tag depending on what they selected. So if they selected low, I'm going to display an H1. If they selected 7, I'm going to display an H2. Actually, yeah. And then if they selected this, I'm going to display an H3. Sort of useless functionality, but it does demonstrate that we can use variables from the model literally anywhere that we want to. Right? That's an H1. 6, 7, the results are a little smaller. It's an H2. I, results are smaller still. So this is what I want to hammer home in this example, that the model and the Razor page work together to create a dynamic piece of HTML. Some of the code is static HTML, which exists in the Razor page. Some of the code exists in the model, which does whatever processing it needs to do and fills up those model variables. Those model variables are then used to populate certain places, certain blanks that are set up on the Razor page. One thing I don't do in this example, I'm going to try to do it real quick. I have to look up how to do it though real quick. What I was going to do, see, we only got like 6 minutes left, so I want to talk about your next assignment. What I was going to do is, if you notice, you'd call this a little flaw in the code or not, is that when you run it, whatever you pick here, after you click play, it takes you back to low. All right, it does display what you displayed. You can actually put C# code in here. put an if statement. If the model choice, if the user's choice equals low, you could then output one thing versus outputting something else. You could output that it's selected. Or that's code you actually could put in the model. But we're a little short on time. We can, if you have questions about that, let me know and I can review that in more detail. What I do want to talk about is I do want to talk about you, what your next homework assignment is, the assignment for week 3. And that is to do a rock, paper, and scissors game. Let me tell you how I see it looking. I see it following a similar format to this. I see you having a web page that contains maybe some radio buttons, could fill in, maybe a drop down, that you could select, maybe images of a rock, paper, scissors. So one of these things, along with it a button, the user clicks. In any case, the result should look something like this. User choice should display an image. Computer choice should display an image, the appropriate image for rock, paper, or scissors, and then there should be a message displaying here saying if it's a win, a loss, or a tie. Make sure you don't display the results the first time, because the first time you're not going to have any results. Therefore, if you have HTML code, you should make it invisible or not displayed. If you want to keep track of how many wins, losses, and ties that are achieved, you're welcome to do that as well, sort of for an extra challenge. Are there any questions over any of this? All right, next week we start our database review. So that'll be a fun class. Hopefully you've all taken CISS243, and we'll go over some basic database concepts. And then we get to merge the two together, and that's where the fun in this course really starts, when we can take these Razor pages and use them to display and manipulate, add, insert, update, delete data values from the database. All right. If there's no questions, that's all I have. We'll see you next week. Oh, by the way, before I go, remember that starting today, I am up in BU 210 for lab. And you can contact me on my WebEx page. So even those of you that aren't here, if you want to attend the virtual lab, just hold tight or come back at like 2 or a little after 2 to my WebEx page, and you can ask me questions and whatever. And this applies to all my classes. I posted an announcement about it. There's a total of 4 times a week that you can do this and attend virtual lab. All right, we'll see you next week.